Hello everyone. Today we'll be solving the problem number 11, container with most water. So just try to read the question and try to understand the same thing with the form of in the by considering the examples as well. So I'll just summarize the question for you so that it will be easier to understand, right? So first, what the question states here, we are given an array height where each element represents the height of vertical line. So this one, we are given an array height where each line represents the this one vertical line drawn at that index, height of the vertical line drawn at that index. You can clearly see here, right, in the figure. So the test is to our main task is to find the two lines that together with the x-axis. They have clearly mentioned here. The task is to find the two lines that together with the x-axis form a container that can hold the maximum amount of water. So the maximum amount of water we have to uh, uh, we have to find out the two lines that together with the x-axis that form a container that can hold the maximum amount of water. That's what we have to find out. So the area of the container is determined by the shorter of the two lines. So here they have clearly mentioned the area of the container is determined by the shorter of the two lines. Suppose in this example we are finding this one, right, area between this one and this one. So we are considering the shorter line. So that is the reason they have showed the water here. So the water is holding from here, right? So we have to consider the shorter line, the second one, the last one, this one, right? And the distance between them. The goal is to maximize this area. Our main goal is to maximize the area. Initially, let's discuss the approach. Then let's discuss the this one, edge cases. So while we discuss the approach and the edge cases, I hope you will get to know the things clearly, right? So initially, let's discuss the. So here we'll be going with the two-pointer approach. So I'll just come here. Let me give here approach. So just give me a second. The first thing is we'll be going with the two-pointer technique, right? So or we'll be going with the two pointers, right? First thing what we'll be doing here is we will start with the widest container. So let's start with the widest container. Always remember we are starting with the widest container. This is the first step. So we will place the two pointers. One is at the beginning and one is at the end here. So beginning nothing but L is at the beginning. This is at the beginning and we'll be considering one more pointer, that is right. Now this will be at the end of the array. So these two pointers will be considering. So we are placing the two pointers. One is at the beginning and one is at the end of the array. Next thing is we have to calculate the area, right? Second thing is we need to calculate the area. That's what we need to do here, right? Maximize the area of the container that it can hold the water. So we have to compute the area as the product of the shorter height and the width, nothing but distance between L and R. We will calculate the distance between L and R. That's what we'll be doing in the second step, right? So first thing, we are going with the two pointers. Just remember this one. Also, we'll start with the widest container. Nothing but we'll set the L to the beginning of the array and R to the end. So these are the two pointers we'll be considering. And the second part here is we have to calculate the area. Nothing but we'll be calculating the distance between L and R, right? So let's move on with the third step. Nothing but we will move the pointer associated with the smaller height. So while I say we move the pointer, let me write here. This is just for the reference. Move the pointer associated with smaller height. So what we'll be doing here, since the area is limited by the shorter height, we'll be moving the shorter line inwards, which gives a chance to find the taller one. So that is the reason we'll be moving the pointer associated with the smaller height. This is important. And the final thing is here, we'll repeat the same process until pointers meet. So repeat until pointers meet. So while we discuss the edge cases, you will come to know this one. Just remember these points. Until pointers meet. We have to update the maximum area here in this process. Repeat until pointers meet. While I say this, I'm just saying we have to update the maximum area that has been found so far, and we have to continue moving the pointers until they overlap. That's what we'll be doing here in this step. Basically, this is the greedy approach, right? A two-pointer approach. This greedy approach will ensure the maximum area that is found efficiently. So next, let's discuss. This is the approach that we'll be going with. Next, let's discuss the edge cases one by one and then write. So let me explain the example first, then let's go with the edge cases, right? So here they have given height this one, and the output that we have got here is 49. So first thing we need to keep in mind is area equals, the formula is area is width into height, right? So here we can clearly see we have to find the maximum, this one, maximum amount of water a container can store here. So we need to consider the smallest, this one, right? Shorter of the two lines. So this one is shorter, so we are considering this one, this line. So height of this one is 7. We can clearly see here. The height of this one is, just give me a second here. Yeah, height is here 7. You can clearly see here. And width, we are going with, this is 1, this is 2, and 3, 4, 5, 6, and 7. So width we have 7. Height is also 7. Area we are going with width into height, nothing but 7 into 7. Here in this case, the output will be 49, right? So that's what they have shown here. So for the second one, we are considering the height 1. Also width we are considering the 1. Let's consider these two lines here. Both have the, suppose just we'll consider both is both the lines here. Yeah, sorry. So here this will be of height 1 and width will be 1 as well. So 1 into 1 here, this will be 1 itself. So that's what they have given here. Let's see the edge cases, right? You will come to know clearly. So just give me a second here. The first edge case, let's consider for the, I'll just give here edge cases, right? So the first edge case that we'll go with here is minimum input size. I'll just consider, let me consider height 1, 1 here. Suppose I'll just come here. Let's consider two vertical lines here. Nothing but this one will be 0, this one will be 1. And height will go with the shorter one. So these both lines are having the equal height, right? So this one, let's consider the height 1 here. This one will be, height will be 1 and width we are having only 1. So 1 into 1 is nothing but 1. So the output will be 1 here, right? So this is for the minimum input, minimum input size. So let's go with the second edge case, nothing but all heights are equal. So I'll just come here. Let me consider 5, 5, 5, some random numbers in the array, but all heights has to be equal here. So let me come here. So let's consider 5 lines here, 5 here. So this one, let it be 1, 2, 3, 4. This will be 5. So all the heights are here equal, right? So the height will be basically 5. To calculate the area, the height will be 5. Area equals, sorry, width into height, right? So the height will be 5 and the width will be 1, 2, 3, and 4. So 5 into 4 will be 20 here. So the output will be 20 here. So the maximum area is determined by the two farthest lines here. Nothing but the output that we got here is 20. This is for the edge case. All heights are equal. I hope this is clear. Let's go with the third edge case, right? So I'll just come here. This one is for the single tall line dominates. So here single tall line will dominate. Suppose I'll just consider here 100, 1 and 1. Suppose this one will be 1, 2, 3, 4, 100 here. So 0 it has to start from, right? So this one will be 1. The second one will be 100. And the third one will be 1. And the fourth one will be 1 as well. So let's start from here. 1. Then we'll be considering this one. Height will be 1 here. 1 into this one. Width will be 3 here. 1 into 3, nothing but width 3. So this one, we have the output will be 3 here. This is for the single tall line dominates here. I'll just write here single tall line dominates here. Nothing but dominates. Just given this way. Let's move on with the next this one edge case, decreasing heights. So let's go with the fourth edge case. Suppose let me consider the input here. Decreasing height we are going with here, right? So 10, 9, 8, 7 and 6 let me consider here. We have to consider from 10 right here. So just give me a second here. Let me go with 0. So let me consider this one from below. Just give me a second here. So first one is 10 here. We have to start from 0. And second one is 9. And third one is 8 here. And fourth one is 7. And the final one is 6 here. So you can clearly see. So the first one is this one. We have to consider the shorter one, right? Nothing but the 6. So area equals nothing but height into width. So let me consider here height as 6. We are considering the shorter line, this one here. And height is 6 and width will be 1, 2, 3 and 4 here. Nothing but 4. Here the output will be 24. So just give me a second. So did I do something wrong here? So yeah, let's continue with this. This one is correct. So this is for decreasing heights. So the output that we got here for this one is 24. This is fair, right? So let's move on with the last edge case. Nothing but one height is 0. I'll just come here. Let me give here one height is 0. So while I say one height is 0, let me consider the input height. Let me consider here one height. This one, let it be 0 here. 8, 6, 2, 5. Let me consider here 0, 2, 3, 4, 5, 6, 7, 8. This one, the first one will be 0. The second one will be 8 here. The third one will be 6. And the fourth one will be 2. And the final one, fifth one will be 5 here. This one we have to consider. So this one 0 and 5, we need to consider this one, right? So 5, let's consider 5 and the width is nothing but here 1, 2, 3. We'll not be considering the 0th one. So this is 0. So we'll be considering from this one 8 basically, the second one, right? 8 and this one 5. The shorter one is this one, and here we'll go with the formula width into height, where width height into width or width into height. Width here is 3. 3 into height is nothing but here 5. This will be 15. So this is for one height is 0. So these 5 edge cases we need to consider here. So the first edge case was here minimum input size. The second one was for all heights are equal. The third one was for basically single tall line which dominates, and the fourth one was for decreasing heights, and the final one is for this one height is 0. I hope all the edge cases are clear, and also the approach is also clear. Let's start writing the code, right? I'll just explain the code while I write the. So here let's start writing the code. Initially, accordingly with the approach, we'll initialize 2 pointers here. So let me consider L. Let me initialize this one to the first index and R to the final index, nothing but R. I'll just give here length minus 1. So we are considering height here, right? Sorry. We have the parameter height here, height dot length minus 1, the last one, and maximum initially we'll consider this one as 0. So we have initialized the 2 pointers here. So next step is we have to loop until the pointers meet. So the condition is, I'll just go with the while loop here. This one L less than R, then I'll just give here area equals math.min of height of this one L, and this one let me consider height of R. This is fine. Finally into R minus L. So this is the formula that we'll be going with, right? So area equals minimum of height of L comma height of R into R minus L. So we are just calculating the current area here. If you didn't get it, we're just calculating the current area over here. After calculating the current area, we have to update the maximum area. To calculate, to update the maximum area, I'll just make use of math.max of. So we'll get the max by area, right? So area, that's what we have considered here, this one. So that's what I am passing here, area. So finally, after updating the maximum area, we have to move the pointer with a smaller height inwards. So just if condition, simple if condition, I'll just give here if height of L less than height of R. So this one, let me increment L, else if height of L is greater than height of R, then we'll be decrementing the right. So we don't have to write the condition again. So I'll just give here else decrement the right pointer. Finally, we have to return the maximum area. We have considered max here, right? So I'll just give here return max. I hope the code is completely clear. So let me format this one and let me hit the run. Let's try to run the code. So here line number 5, let area, this one has to be equals. So let me run this code again. Wrong answer we are getting. So output 8 we are getting, somewhere we have done the mistake. Let's check what. So here I have misplaced the bracket here. This one I have to close here. So this is the mistake that I had done. Let me run the code again. So here you can see the sample test cases are getting passed. Let me hit the submit now. So you can clearly see the code works absolutely correct, right? Finally, let's discuss the time complexity and the space complexity of the code. So the approach that we went with here is this one, 2 pointers. So what will be the overall time complexity here? We are moving the each pointer at most once through the array. You can clearly see here we are moving the pointer at most ones through the array. So the overall time complexity would be big O of n here. I'll just give here big O of n. And what will be the space complexity here? The overall space complexity would be big O of 1. So I'll just give here big O of 1. So why the space complexity here is big O of 1? Because we are not making use of any additional space right here. We are just making use of the few variables and we are not making use of any additional space. So the overall space complexity would be big O of 1 as well. So I hope the solution is completely clear now. So this is it. Thanks for watching, guys.